Hello and welcome to lesson 1.1, lines. So today we're going to look at some things from grade 9 and grade 10 that you might have done, even some explanations and some ideas from grades 11 and moving forward to grade 12. So recall the slope of a line can be calculated in many different ways. So we can use y2 minus y1 over x2 minus x1, where x1, y1 is a point on the line, and so is x2, y2. You can also use your change in your y values over your change in your x values. You can also call this rise over run. So you can use all these different possibilities, and you can even change it now to function notation. So f of x2 minus f of x1 all over x2 minus x1. If you have a function. So to actually calculate the coordinate increments from the point 1, 3 to the point 4, 9, we can use that to also calculate our slope. So the coordinate increments, in other words, are your values for change in x and change in y. So the change in x went from 1 to 4, so 4 minus 1, which is the value 3. And the other one went from 3 to 9, so 9 minus 3 is 6. So using that, change in y over change in x is 6 over 3, which is equal to 2. So this is your slope. Okay, moving right along. Well, recall that lines can be described as usually a diagonal line. You could also have horizontal lines and vertical lines. We'll talk about that in a little bit. But there are many different properties to these things. Lines are usually listed in the form y equals mx plus b if you're looking for it in slope y-intercept form. But realize that the form isn't always going to be slope y-intercept form. To calculate your slope, again, you can use rise over run. So change in y over change in x, or rise over run. You can also realize that the slope is actually a value of tan theta. Where this value of tan theta is opposite over adjacent, or change in y over change in x. Now lines with the same slope are considered parallel, and lines with slopes that are negative reciprocals of each other are considered perpendicular. Okay, so lines in the standard form are usually in the format ax plus by plus c equals 0, where the values of a, b, and c are usually integers. Are integers. And the value of a is always greater than 0, or the leading coefficient is always greater than 0. This allows us to actually write the equation of a line without having to use any fractions or decimals. Horizontal lines are usually of the form y equals some value a, where a is some real number. And vertical lines are usually of the form x equals b, where b is equal to some real number. Okay, so the point slope form of line is usually written in the format y minus y1 equals m of x minus x1. This stems from the idea that we can recall the slope is y2 minus y1 x2 minus x1. If you replace just the y2 and the x2 with a general variable, and then you cross multiply the x minus x1 up with the m, you get point slope form. Another way of looking at it is you're looking at the slope of a line and translating it based on your x value and your y value, and just not adding the y value to it, you're subtracting it off the left-hand side. Okay, so let's determine the equation of a line in standard form, point slope form, slope y-intercept form, with a slope of 2/3 and goes through the points 6 and 5. So me personally, I'm going to write y equals mx plus b to start with. I know my value for m in this case is 2 or 3. I also know my value for y is 5 and my x is 6. So 2/3 of 6 is 4. So my value for b is 5 minus 4, which is 1. So here I have my slope y-intercept form. If I wanted to do point slope form, well, my y minus 5 equals 2/3 of x minus 6. That's it, simply. Takes the point, takes the slope, you're done. The last part is you rearranging these equations. So to get standard form, I'm going to take this one right here, and I'm going to multiply everything by 3. So I got 3y equals 2x plus 3. Now I'm going to rearrange everything and move it all to the left-hand side. So 2x minus 3y plus 3. I move it to the right-hand side because that leaves the leading coefficient x as a positive. So 2x minus 3y plus 3 equals 0 is my standard form of my line. And there you go. That's how you work out your standard form of your line, your point slope form of your line, and your slope y-intercept form of your line. And thus concludes this lesson.